The chemical you just saw was nitrogen triiodide. Nitrogen triiodide is an extremely sensitive contact explosive, which means its solid form can detonate into a cloud of purple vapor at the slightest touch. Nitrogen triiodide is so sensitive it can even be triggered by alpha particle radiation. This demo will cover both the synthesis and detonation of nitrogen triiodide using iodine crystals and ammonium hydroxide. Through this demonstration, we will observe a variety of chemistry themes such as enthalpy, entropy, spontaneity, steric strain, and an energy of reactions.
As you can see here, the nitrogen triiodide is synthesized from the iodine crystals and the ammonium hydroxide. Now the iodine crystals will be mixed with the ammonium hydroxide to form the nitrogen triiodide. After filtering, the nitrogen triiodide solid was obtained. As you can see now, we are painting the nitrogen triiodide onto filter paper. This will be left to dry for an hour or two.
Now we're going to look at the decomposition reaction. If you look at the products, we see nitrogen gas and iodine gas. Nitrogen is colorless and it's the most abundant gas in our atmosphere, whereas iodine is a purple gas. And so when we detonate the samples of nitrogen triiodide, you should see a big cloud of purple gas.
The reason nitrogen triiodide is so sensitive is because of steric strain. Steric strain occurs in a molecule when the atoms in the molecule repel each other because of their valence electrons. Here's a model of steric strain. As you can see, the iodines are much bigger than the lone nitrogen. The lone pairs in the iodine repel each other, so with a slight touch, they explode.
In addition to steric strain, there are several factors of thermodynamics that contribute to nitrogen triiodide sensitivity. Enthalpy, which is the heat of reaction, is negative because the decomposition reaction releases 290 kilojoules per mole reacted. Entropy, which is a measure of how disordered the system is positive because we begin with the solid nitrogen triiodide and then it decomposes into two gases. Entropy or disorder is favored in a reaction. The universe wants things to become more disordered, and so because a solid is becoming into two gases which are more disordered than solids, the forward reaction in the detonation is favored. Negative enthalpy and positive entropy combine to contribute to the Gibbs free energy, which in this case is positive. If Gibbs free energy is positive, that indicates that the reaction is spontaneous.
Finally, the activation energy for this reaction is very low. The diagram on the left indicates a reaction that requires a lot of energy before it proceeds, but the diagram on the right better represents the decomposition of nitrogen triiodide because its activation energy is low. Since activation energy is so low, nitrogen triiodide doesn't need much help getting started.
Here's some more examples of nitrogen triiodide decomposition.
Okay. Nice.